In this video, I will explain the operation of a 4-to-1 multiplexer and a 1-to-4 demultiplexer. Okay, I'll now explain the operation of a 4-to-1 multiplexer circuit. Here on the left side, we have a 4-to-1 multiplexer circuit. Now note, we have two address lines, B and A, and the NOT provide for the NOT B. This first one is NOT B, the second one is NOT A. These are all required to provide the correct addressing for each gate. All right, now data 0 is fed through this first AND gate, data 1 through the second AND gate, data 2 through this third AND gate, and data 3 through this fourth AND gate to the output. Right, now data 0, the data 0's gate is addressed by having 0, 0 on the input. So let me start the simulation. So if you have 0, 0 on the input or on the address line, note that the 0 comes out as a 1 from NOT B, and it comes out as a 1 from NOT A. Now that is to enable the gate, the first gate. See, the green here says that there are two 1s on this gate, which this gate is ready now to be able to transmit the data through it, right? So 0, 0 actually is the address line to enable this gate, because 0, 0 input through the NOT gate actually gives you two 1s. So now, if I toggle the data here, you will see, if you focus on the data output here, you will see that the data is changing, all right? Because that data line is addressed. If I try to toggle, if I toggle data 1, nothing happens because data 1 is not selected. Or data 2, toggle, nothing happens. Data 3, nothing happens. Now, if I want data 1 to be selected, data 1, I have to have 0 on B and a 1 on the address, on the A address line. So now, you can see the two yellow dots indicate that this gate is now ready to transmit data. So if you go data 1, I toggle that, I can see the bit is passing through. But if I try data 0, nothing happens. If I try data 2, nothing happens. If I try data 3, nothing happens. Now to select data 2, I now have to have a 1 on the B and a 0 on the A, right? So now you see the gate is now ready to transmit data 2. See, data 2 goes through, okay? And then finally, to transmit data 3, I must have a 1 on the B and a 1 on the A. Right, now see, gate number 4 is now ready. So data 3 can come out, but no other data can come out. Right? No other data can come out. All right. So what we have done, we have multiplex. We have 4 bits of data that we are multiplexing into one line to go into the output. All right. So it's a 4-to-1 multiplexer. It has 2 address lines. Now on the next section, we will look at the demultiplexer, which takes the input from a multiplexer and recovers the data. Let us now look at a 1-to-4 demultiplexer, which will take the data from the 4-to-1 multiplexer and recover it at its output. So here we have the 1-to-4 demultiplexer made of 4 AND gates, and the AND gates are all addressed from the same address lines as we had for the multiplexer, okay? B and A, right? And the data is in now. Now there's one data line in, and the multiplexer will separate them out into 4 separate data outputs, right? So let's see how this works. if we address 0, 0, note that, let's have all the data off. Note that this gate, the top gate here, has 2 green dots on it, means that there are 2 ones on there, and this gate is ready to decode or recover the data that was occurring, that is occurring at the data input 0 here. All right, so if I toggle the data input 0 here, see, the data is changing here. At the same time, it is changing over here, right? If other data is moving, okay, if other data is moving, it doesn't get through because that particular line is not addressed. If I want data 1 to go through, now to get out to be demultiplex, I now have to select address data 2 line, the data 1 line, sorry. Now look at here, you see the 2 green dots indicate that the data 1 line now is ready to transmit data. So if I go to data 1 and I toggle data 1, I see that it's faithfully reproduced at the output. All right, and no other data can get through, right? All right, so if I want to know data 2, I have to address data 2. I have to have a 1 and a 0, right? If I now toggle data 2 is faithfully reproduced at the output. Note as I toggle, the data is showing up at the data output for the multiplexer. That is fed on one line, but is then demultiplexed to be recovered at the output. All right, now if I want to transmit data 3, I must address 1, 1, okay? And now if I toggle data 3, you will see that data 3 now will be transmitted out at data 3. Data 3 that has been multiplexed on one line has been now transmitted out and recovered at data 3 from the demultiplexer. All right, so to summarize, you have a multiplexer circuit, multiplexer, many in, a single out. A demultiplexer is a single in, many out. Okay, and once the address lines are synchronized, are the same, are operating at the same time, you will faithfully recover whatever is in at the multiplexer can be recovered at the demultiplexer.